Huh. In the name of Allah, who is the most beneficent and most merciful. My name is Areej from Department of BS Chemistry. I am going to present the topic applications of paints. Paints can be applied as a solid, a gaseous suspension, for example, aerosol or a liquid. Techniques vary depending on the practical or artistic results desired. First, it is applicable as a solid. As a solid usually used in industrial and automotive applications, the paint is applied as a very fine powder, then baked at high temperature. This melts the powder and causes it to adhere to the surface. The reasons for doing this involve the chemistry of the paint, the surface itself, and perhaps even the chemistry of substrate, which is the overall object being painted. Applications of paints as a gas. As a gas or as a gaseous suspension, the paint is suspended in liquid or solid form in a gas that is sprayed on an object. The paint sticks to the object. The reasons for doing this include the application mechanism is air, and thus no solid object ever touches the object being painted. The distribution of the paint is very uniform, so there are no sharp lines. It is possible to deliver very small amounts of paint or to paint very slowly. A chemical, typically a solvent, can be sprayed along with the paint to dissolve together both the delivered paint and the chemicals on the surface of object being painted. Some chemical reactions in paint involves the orientation of the paint molecules. Applications of paints as a liquid. In the liquid application, paint can be applied by direct application using brushes, paint rollers, blades, other instruments, or body parts. For example, body parts include fingerprinting, where the paint is applied by hand, whole body painting, popular in the 1960s avant-garde movement, and cave painting, in which a pigment, usually finely ground charcoal, is held in the mouth and spat at a wall. Rollers generally have a handle that allows for different lengths of poles, which can be attached to allow for painting at different heights. Generally, roller application uh, takes two coats. Generally, roller application takes two coats for even color. A roller with a thicker nap is used to apply paint on uneven surfaces. Edges are often finished with an angled brush. After liquid paint is applied, there is an interval during which it can be blended with additional painted regions. At the wet edge, called open time. The open time of an oil or alkyd based emulsion paint can be extended by adding widespread similar glycols such as dovanol, propylene glycol ether, or commercial open time prolongers. This can also facilitate the mixing of different wet paint layers for aesthetic effect. Latex and acrylic emulsions require the use of drying retardants suitable for water-based coatings. Then I will talk about product variants of paints. First of all, primer. Primer is a preparative coating put on materials before applying the paint itself. The primer surface ensures better adhesion of the paint, thereby increasing the durability of the paint and providing improved protection for the painted surface. Suitable primers also may block and seal stains or hide a color that is to be painted over. Second is emulsion paints. Emulsion paints are water-based paints in which the paint material is dispersed in a liquid that consists mainly of water. For suitable purposes, this has advantages in fast drying, low toxicity, low cost, easier application, and easier cleaning of equipment among other factors. Next is varnish and shellac. Varnish and shellac are in effect paints without pigment. They provide a protective coating without substantially changing the color of surface, though they can emphasize the color of material. Next, wood stain. Wood stain is a type of paint that is formulated to be very thin, meaning low in viscosity, so that the pigment soaks into a material such as wood rather than remaining in a film on the surface. Stain is mainly dispersed pigment or dissolved dye plus binder material in a solvent. It is designed to add color without providing a surface coating. Lacquer. Lacquer is a solvent-based paint or varnish that produces an especially hard, durable finish. Usually, it is a rapidly drying formulation. Enamel paint is formulated to give an especially hard, usually glossy finish. Some enamel paints contain fine gloss powder or metal flake instead of the color pigments in standard oil-based paints. Enamel paint sometimes is mixed with varnish or urethane to improve its shine and hardness. Next is glaze. Glaze is an additive used with paint to slow drying time and increase translucency as in fox painting and for some artistic effects. Roof coating. A roof coating is a fluid that sets as an elastic membrane that can stretch without harm. It provides UV protection to polyurethane foam and is widely used in roof restoration. Fingerprints. Fingerprints are formulations suitable for application with the fingers. They are popular for use by children in primary school activities. And inks are similar to paints, except that they are typically made using finely ground pigments or dyes and are not designed to leave a thick film of binder. They are used largely for writing, printing, or calligraphy. Next is anti-graffiti coatings. Anti-graffiti coatings are used to defeat the marking of surfaces by graffiti artists or vandals. There are two categories of anti-graffiti coatings, sacrificial and non-sacrificial coatings. Sacrificial coatings are clear coatings that allow the removal of graffiti usually by washing the surface with high pressure water that removes the graffiti together with the coating. After removal of the graffiti, the sacrificial coating must be reapplied for continued protection. Such sacrificial protective coatings are most commonly used on natural looking masonry surfaces such as statuary and marble walls and on rougher surfaces that are difficult to clean. And second is non-bonding coatings. Non-bonding coatings are clear, high-performance coatings, usually catalyzed polyurethanes that do not bond strongly to paints used for graffiti. Graffiti on such a surface can be removed with solvent wash without damaging either the underlying surface or the protective non-bonding coatings. These coatings work best on smooth surfaces and are especially useful on decorative surfaces such as mosaics or painted murals, which might be expected to suffer harm from high pressure sprays. Sacrificial coatings are work best on rougher surfaces, and non-bonding coatings work best on smooth surfaces. Next is urine repellent paint. Urine repellent paint is a very hydrophobic paint which is water repellent, and it has been used by cities and other property owners to deter men from urinating against walls as the urine splashes back on their shoes instead of dripping down the wall. Anti-glim paint is a non-drying paint that appears normal, but it is extremely slippery. It is useful on drain pipes and ledges to deter burglars and vandals from climbing them, and is found in many public places. When a person attempts to climb objects coated with the paint, it rubs off onto the climber, as well as making it hard for them to climb. Next is anti-fouling paint. Anti-fouling paint or bottom paint prevents varnish and other marine organisms from adhering to the hulls of ships. Insulative paint are also called insulating paint, which reduces the rate of thermal transfer through a surface it's applied to. One type of formulation is based on the addition of hollow microspheres to any suitable type of paint. Anti-slip paint contains chemicals or grade to increase the friction of surface so as to decrease the risk of slipping, particularly in wet conditions. Next is road marking paint. Road marking paint is specially used to marking and painting road traffic signs and lines to form a durable coating film on the road surface. It must be fast drying, provide a thick coating, and resist wear and slipping, and especially in wet conditions. Luminous paints. Luminous paints are luminescent paint is paint that exhibits luminescence. In other words, it gives off visible light through fluorescence, phosphorescence, or radioluminescence. Uh, Chalk paints is a decorative paint used for home decor to achieve looks with such as shabby chic or vintage with home decor. Next, I will talk about types of finishes. There are 6 types of finishes. First is flat finish, second matte finish, third eggshell finish, fourth pearl satin finish, fifth semi-gloss finish, and sixth high gloss finish. First, I will talk about flat finish. Flat finish paint is generally used on ceilings or walls that are in bad shape. This finish is useful for hiding imperfections in walls, and it is economical in effectively covering relatively great areas. However, this finish is not easily washable and is subject to staining. Second, I will talk about matte finish. Matte finish is generally similar to flat finish, but such paints commonly offer superior washability and coverage. It is most common of interior wall paints. Third is eggshell finish. Eggshell finish has some sheen, supposedly like that of the shell on an egg. This finish provides great washability but is not very effective at hiding imperfections on walls and similar surfaces. Eggshell finish is valued for bathrooms because it is washable and water repellent, so that it tends not to peel in a wet environment. Fourth is satin finish. Satin finish is also called pearl finish. It is very durable in terms of washability and resistance to moisture, even in comparison to an eggshell finish. It protects walls from dirt, moisture, and stains. Accordingly, it is exceptionally valuable for bathrooms, furniture, and kitchens. But it is shinier than eggshell, so it is even more prone to show imperfections. Fifth is semi-gloss finish. Semi-gloss finish typically is used on the trim to emphasize detail and elegance and to show off woodwork, such as on doors and furniture. It provides a shiny surface and provides good protection from moisture and stains on walls. Its gloss does, however, emphasize imperfections on the walls and similar surfaces. and it is popular in schools and factories where washability and durability are the main considerations. And the sixth and last type of finish is high gloss finish paint. A high gloss paint is a highly glossy and super shiny form of paint, and that is light reflecting and has a mirror like look, which is also seen in diagram. It pairs well with other finishes. While it is highly durable and easy to clean, high gloss paint is known for obvious visibility of imperfections like scratches, dents. Next, I will talk about the pre-treatments for painting. Here is the contents. There are 5 treatments that includes in pre-treatment: cleaning, rinsing, surface conditioning, some other choices for painting, and zinc phosphate coatings. Cleaning process also includes 2 types: solvent cleaners and alkaline cleaners. And other choices means iron phosphate pre-treatment system, and second is zinc phosphate pre-treatment system. First, I will talk about cleaning. Um, Better adhesion, enhanced corrosion and blister resistance, and reduced coating part interactions make pre-treatment a must. A high quality conversion coating is essential for the durability of painted metal goods. The process of applying an inorganic conversion coating to a metallic surface involves removing any surface contaminants. Conversion coatings increases the overall surface area and promote adhesion of the subsequently applied organic film. In addition, it changes the chemical nature of the surface, which increases corrosion resistance. It is these 2 functions, increasing surface area and changing the surface chemistry, that also serve as a base for preparing the substrate material for paint finishes. There are a number of driving forces in the pre-treatment industry today, with quality, cost, and the environment being the most predominant. While these are not new issues, the pre-treatment industry has responded to the needs of finishers by creating technology to address each of these requirements. In understanding the complete manufacturing process, including formulations, application equipment, and regulatory impacts, it's possible to address each driver simultaneously. The first pre-treatment process is cleaning. To increase the effectiveness of finish, parts must be cleaned prior to coating. Aqueous cleaning, vapor degreasing, or ultrasonic cleaning are typical cleaning process, and of the 3, aqueous cleaning makes up the majority. For parts that will subsequently be finished with organic coatings, surface pre-treatment is required. Depending on the chemistry, iron phosphate systems can either be a cleaner coater, where the cleaning and coating take place in the same stage, or have a separate cleaning stage. Separate cleaning steps are essential for zinc phosphate system and the new phosphate-free and low phosphate conversion coatings. If the cleaner does not fulfill its purpose of removing unwanted soils from the substrate, subsequent processing steps will not produce a uniform conversion coating and therefore adequately protect the metal surface from corrosion. Typical soils are either organic or inorganic. Rust preventive oils and lubricants, metal forming blends, and rolling oils are examples of organic soils. Inorganic soils include mill or heat scale, metallic fines, and laser scale. There are 3 types of cleaners that are mostly used in metal finishing: solvent cleaners, acid cleaners, and alkaline cleaners. Using the proper cleaner for the application is critical since the method of cleaning can affect coating characteristics such as coating weight, crystal structure, as well as subsequent coating performance. Here I am going to discuss two of the cleaners, which is solvent cleaners and alkaline cleaners. Solvent cleaners are usually used on small surfaces, areas, and offer limited ability to remove difficult oils. Solvent usage is diminishing in favor of more environmentally friendly options. Acid cleaners are chosen for removing inorganic soils such as surface oxides. Alkaline cleaners deliver optimum results in organic soils. These cleaners are versatile enough to effectively clean the surface by lifting the soil up and dispersing it into the main cleaner bath, where it is held until it is removed mechanically using thermal oil separation, ultrafiltration, or by overflowing the cleaner tank to drain off surface oils. The second pre-treatment is rinsing. Proper rinsing is a critical yet often overlooked step in the pre-treatment process. The water rinse process stops chemical reactions from taking place and removes untreated chemicals from the part's surface. Effective water rinsing also minimizes the migration of chemicals from one processing stage to the next. For effective rinsing, keeping the rinse water fresh reduces the amount of contamination which is present on the surface of parts. The key is controlling the amount of surface contamination on the part. If there is only a single rinse stage, then a freshwater halo um, can be installed in between the chemical and water rinse stage rather than adding fresh water to the main tank. This allows the rinse tank to run at higher levels of contamination while the halo adds fresh water to the tank. But more importantly, it floats the pot and reduces the surface contaminations. In the other case of multiple rinse stages, they are counter flowed and can effectively minimize water which is used in the rinse stages, requiring only a fraction of the water volume and reducing the amount of effluent produced. We can also reduce water consumption by optimizing our equipment design with proper racking of parts. Other choices for pre-treatment are for have been either an iron or zinc phosphate, which provided the degree of performance necessary for operation. Recently, there have been developments to replace this traditional technology with products that address ever-growing concerns with energy and water usage, environmental impact, and the general operation of the process. First process is iron phosphate pre-treatment system. Iron phosphate system, also known as alkali metal phosphate, are used for parts that require a durable finish but are not exposed to severely corrosive environments. These systems can involve 2 to 6 stages, with the shortest sequence being a cleaner coater stage followed by a tap water rinse. Short sequence systems are employed if performance requirements are low. Parts that are more difficult to clean or have higher quality requirements call for a separate cleaning stage. Appropriate rinse tanks, iron phosphate, post-treatment rinse, and DI rinse. A post-treatment rinse, chrome or non-chrome, results in improved chromium performance over the phosphate alone. Iron phosphate produces an amorphous conversion coating on steel that ranges in color from iridescent blue to gray, depending on operating conditions and product formulation. Mixed metals may be treated with modified formulas that typically contain fluoride. Iron phosphate processes are much easier to operate and require fewer process stages than zinc phosphate. Uh, However, iron phosphate do not provide the degree of corrosion protection imparted by zinc phosphates. The second pre-treatment system is zinc phosphate. Zinc phosphate system varies from an iron system in two critical areas. First, it requires the use of surface conditioner stage. Second, a zinc phosphate bath has additional metal ions in the solution which are incorporated into the coating along with metal ions from the substrate being processed. The fourth pre-treatment surface conditioning. Surface conditioning rinses are used in zinc phosphating to refine crystal morphology and control coating weight. State-of-the-art conditioners are liquid products that can be consistently applied using metering pumps. The surface conditioning rinse takes place just before the zinc phosphate stage and is the only step in the process that is followed by another chemical stage, the zinc phosphate bath. The traditional surface conditioning chemistry is a colloidal suspension of titanium salt. As these traditional baths age, they become less effective and must be dumped frequently or overflowed to maintain effectiveness. But recently, zinc phosphate has been used to replace the titanium salt chemistry. This technology improves the refinement of the zinc phosphate coating, yet is not affected by the chemical makeup of the water or bath age. And the last pre-treatment process is zinc phosphate coating. Zinc phosphating coatings provide exceptional painted part durability in corrosive environments and have the ability to coat mixed metals, for example, steel, zinc coated steel, and aluminium. Several small developments have taken place over the past few years, such as decreasing the environmental impact and improved performance and ease of evaporation. Um, sorry, operation. New zinc phosphate systems operate at lower temperatures, in some cases are free of nitrites and nickel, and offer a reduction in sludge, and some products are internally accelerated. The objects of the products were to increase quality, operate easily, and in case of internally accelerated systems, eliminate the need for additional accelerators. Depending on the metal mix in the system, additives are used to assist in the formation of conversion coating on substrate. For example, free fluoride added to the bath optimizes the conversion coating on aluminium or zinc. Adding calcium ions to the zinc phosphate bath produces a microcrystalline phosphate coating, which is needed for rubber bonding. Depending on the final application and performance requirements, various other metal ions, organic acids, chelating agents, and other chemicals can modify the overall characteristic of the zinc phosphate conversion coating. Over the years, zinc phosphating coat systems have evolved from conventional systems, which contains high levels of zinc and nickel, which is accelerated by sodium nitrite. An additional metal ion, manganese, was incorporated into the base chemistry to create the polycrystalline system, which is used today. Current polycrystalline systems can be either internally or externally accelerated, but in some process, nickel was removed to create a nickel-free process. Next, I will talk about post-treatment for painting. Here are the contents of post-treatment for painting includes phosphate coating evaluation, in which we also discuss three factors: coating weight, crystal structure, and coating composition. Introduction of post-treatment for painting. After a metal surface receives the conversion coating, the surface is water rinsed to remove unreacted chemicals, and post-treatment may be applied. The post-treatment can increase corrosion and humidity resistance as compared with conversion coatings without final rinses. In the case of electrocoat applications, final deionized or reverse osmosis water rinse is required to minimize dragging of high conductivity water on the substrate surface from the post rinse. In these cases, it is imperative to have a reactive final rinse that maintains its properties after the deionized or reverse osmosis rinses rather than a dry in place rinses. Post treatments historically um, have been based on chromic acid with more stringent effluent guidelines. Most finishers have converted to either trivalent chrome or non-chrome post treatments. The automotive industry have set standards to virtually eliminate the use of hexavalent chrome in vehicles produced after 2007. Recent advances in dry in place polymeric post treatments have shown excellent results when compared with standard non chrome or deionized rinse systems. Phosphate coating evaluation. The- there are three characteristics that define a conversion coating: coating weight, crystal size or morphology, and the chemical composition. When within the design specifications for application and material, all three characteristics contribute to ensuring the proper and expected adhesion and corrosion performance. First is coating weight. Coating weight is defined as the amount of coating deposited within a specific surface area. Typically, coating weight is expressed in either grams per square meter or milligrams per square foot. Each conversion coating technology is designed to deposit a specific coating weight on the substrate. Coating weight is an excellent indicator of whether the conversion coating bath is in proper chemical balance. If the coating weight is low and outside the specific range, something may be wrong within the process and immediate attention is required. Second is crystal structure. The crystal structure of convection coating is measured through use of microscope, either an optical or most commonly a scanning electron microscope, at magnifications ranging from 100 to 1000 times. In case of new generation coatings, this magnification is not sufficient, and other instruments such as atomic force microscope or field emissions microscope are necessary to achieve visible images of coatings at 30,000 times and greater. Regardless of instrument required, the conversion coating is a combination of crystalline and microstructures chemically deposited on the metal surface, and the instrumentation is used to determine the size, shape, and uniformity of the coating. Third is coating composition. In addition to coating weight and crystal structure, the chemical composition of coating plays a significant role in corrosion performance. Basically, corrosion is alkaline in nature. So the more alkaline resistance a coating delivers, the better the corrosion performance. Chemical composition can be determined through a simple analysis in laboratory using more advanced equipment such as scanning electron microscope with energy dispersive X-ray or X-ray diffraction. Use of this type of equipment is impractical on site but can effectively evaluate performance in a laboratory setting. The chemical composition of coating can help troubleshoot the process in applications where corrosion performance is below expectations. That's all from my side. Thank you.